August 17, 1943, 7:42 in the morning. The sun was already beating down on Dobodura Airfield in New Guinea, turning the metal skin of the parked aircraft into furnaces. Technical Sergeant James McKenna crouched beneath the left wing of a P-38 Lightning, his hands stained with grease and hydraulic fluid, his eyes fixed on something that had been haunting him for months. Above him, Lieutenant Robert Hayes was going through his pre-flight checklist. 23 years old. 6 combat missions. In less than an hour, he would be flying straight into a formation of 18 Japanese Mitsubishi A6M0 fighters. McKenna had been maintaining P-38s for 8 months at this airfield carved out of the jungle, and he knew something that the engineering officers refused to acknowledge, something that was costing American lives every single day. The P-38 Lightning was unlike any other fighter aircraft in the war. Its twin-boom design made it instantly recognizable. Twin engines meant redundancy, a pilot's insurance policy over the vast emptiness of the Pacific. Speed at high altitude was exceptional. Firepower was devastating, with 4 50 caliber machine guns and 1 20mm cannon, all concentrated in the nose. No propeller to fire through, no synchronization needed. When a P-38 pilot pressed the trigger, he unleashed a cone of destruction that could tear apart enemy bombers. But there was a problem, a fatal flaw that pilots whispered about in their tents at night, that ground crews discussed in hushed tones as they worked. The P-38 could not turn with a 0. In a dogfight, that difference meant everything. The lighter, more agile 0 could execute a turning maneuver in half the time it took a P-38, and in aerial combat, half a second was an eternity. It was the difference between getting your guns on target and having the enemy slip behind you, the difference between going home and never coming back. McKenna had seen it happen too many times. Pilots would return with stories of how they had the advantage, how they had the altitude and the speed. But when it came to the turning fight, the 0 would simply outmaneuver them. Some pilots never returned at all. Their P-38s would be found later, if they were found at all, crashed into the jungle or floating in pieces on the ocean. The official explanation from the engineering officers was always the same. The P-38 was a high-altitude interceptor. It wasn't designed for low-altitude dogfighting. Pilots needed to use energy tactics to maintain speed and altitude advantage, to never get drawn into a turning fight with a 0. The problem, they said, wasn't the aircraft. It was pilot technique. But McKenna knew better. He had spent hundreds of hours working on these machines. He understood them in a way that engineers in California could never understand them, because he saw what happened to them in combat. He saw the stress cracks, the wear patterns, the way systems performed in the heat and humidity and violence of the Pacific theater. And he had discovered something so simple that it seemed impossible it had been overlooked. The P-38's aileron control cables, the cables that ran from the control stick through the fuselage to the tail section and out to the ailerons on the wings, had slack in them. Not much, just 3/8 of an inch at full deflection. In the controlled environment of a factory test, with an engineer measuring cable tension with precision instruments, that amount of slack was within specifications, within tolerance. But in combat, that 3/8 of an inch created a delay. When a pilot moved the stick, there was a fraction of a second before the aircraft responded. At high speed, with altitude to spare, this delay was manageable, barely noticeable. But in a low-speed turning fight where every fraction of a second mattered, it was fatal. McKenna had tried to explain this to the engineering officer. He had shown him the cables, demonstrated the slack, explained how it created a lag in the aircraft's response. The response he received was dismissive. The cable tension was within specifications, straight from Lockheed. Any field modification would void the warranty and potentially compromise the structural integrity of the aircraft. Besides, no mechanic had the authority to alter flight control systems. That required engineering approval, testing, certification, proper channels, while pilots continued to fall. McKenna stood there under Hayes's P-38, watching the young pilot above him, and made a decision. It was a decision that could get him court-martialed. It was unauthorized. It violated regulations. It contradicted everything the Army Air Forces had approved. But it was right. He had already prepared the modification. A 6-inch piece of piano wire, salvaged from a damaged aircraft that would never fly again. He had bent it into a Z-shape, creating a simple tensioner. 8 minutes. That's all it would take to install. 8 minutes to eliminate the slack in the control cables. 8 minutes that might save Lieutenant Hayes's life. McKenna worked quickly. His hands moved with the practiced efficiency of a man who knew his craft. Remove the access panel, locate the cable run, install the tensioner, check the tension, replace the panel. When he was finished, there was no visible sign of the modification, but the slack was gone. When Hayes moved his control stick, the aircraft would respond instantly. McKenna said nothing to the pilot. What could he say? That he had just performed an unauthorized modification on his aircraft? That he had violated regulations? That he had taken it upon himself to redesign part of the flight control system? Hayes climbed into his cockpit, ran through his checks, and taxied out to the runway, completely unaware that his P-38 was no longer exactly the same aircraft he had flown the day before. 7 minutes after takeoff, Hayes's voice crackled over the radio. Contact with enemy fighters. 18 zeros, just as intelligence had predicted. The pilots at Dobodura who weren't flying that mission gathered around the radio in operations, listening to the snippets of communication. Short, terse radio calls, altitude, heading, numbers, then silence. Minutes stretched into what felt like hours. The mechanics worked on other aircraft, trying to keep busy, trying not to think about what was happening out there over the Bismarck Sea. Then, 1 hour and 12 minutes after takeoff, the P-38s began to return. Hayes's Lightning came in first. As soon as his wheels touched the runway, even before the aircraft had fully stopped, McKenna was running toward it. Hayes climbed out of the cockpit, his face flushed with excitement and adrenaline. 3 confirmed victories, 3 zeros, in 7 minutes of combat. The other pilots gathered around, wanting to know what had happened. Hayes described it, still catching his breath. The Zeros had tried to draw him into a turning fight, their standard tactic. But this time, something was different. The P-38 responded faster, sharper. He could stay with them in the turns. Not quite as tight as a Zero, but close enough. Close enough that his superior speed and firepower made the difference. McKenna stood back, listening. He said nothing, but Hayes caught his eye and something passed between them, an unspoken understanding. The pilot didn't know exactly what had been done, but he knew something had changed. Word spread fast among the ground crews, not through official channels, through the informal network that existed among the mechanics and crew chiefs who kept the aircraft flying. By nightfall, 3 more P-38s had received the modification. By the end of the week, it was a dozen. By mid-September, 40 P-38s at Dobodura had McKenna's piano wire tensioner installed. The change in combat results was dramatic. Pilots who had previously struggled against the Zero were now achieving favorable outcomes. The unequal exchange rate began to shift. Before the modification, American pilots in the Pacific were facing difficult odds. Afterward, the balance began to even. The Japanese pilots noticed something had changed. Intelligence intercepts would later reveal their confusion. The American P-38s were suddenly performing differently. The tactics that had worked before weren't working anymore. The psychological advantage that the Zero pilots had enjoyed, the confidence that they could always outturn the enemy, began to erode. From the Japanese perspective, it must have seemed inexplicable. These were the same P-38s they had been fighting, the same pilots mostly, but suddenly the Americans were more dangerous, more aggressive in the turns, more willing to engage in close combat. What had changed? The modification spread beyond Dobodura. Crew chiefs talked to other crew chiefs. Mechanics transferred to other units and brought the knowledge with them. No official orders were ever issued. No technical directives came down from headquarters. It was a grassroots movement, spreading mechanic to mechanic, crew chief to crew chief, across the Pacific Theater. The Army Air Forces eventually became aware of the unauthorized modifications. By that point, the results were undeniable. Pilot survival rates had improved. Combat effectiveness had increased. There was a simple correlation between P-38s with the modification and P-38s that came back from missions. A lesser bureaucracy might have cracked down, might have court-martialed the mechanics involved, might have insisted on proper channels and official approval and testing protocols. But someone, somewhere up the chain of command, made a pragmatic decision. If it works, don't fix it. If it's saving pilot lives, don't stop it. Lockheed Aircraft Corporation, the manufacturer of the P-38, eventually integrated a similar tensioning system into the P-38J model, which began production in the spring of 1944. It was a more sophisticated version of McKenna's piano wire, engineered and tested and certified. But the principle was exactly the same. Eliminate the slack in the control cables. Improve the aircraft's response time. McKenna's name appeared nowhere in the technical documentation. No credit. No recognition. Just another anonymous improvement in the long evolution of the aircraft. The official history would record that the P-38J featured improved aileron response, making it more effective in dogfighting situations. But it wouldn't mention the mechanic at Dobodura who figured it out first, using a piece of salvaged piano wire and 8 minutes of unauthorized work. The P-38 Lightning would go on to become one of the most successful American fighters in the Pacific Theater. It was the aircraft flown by America's top two aces, Major Richard Bong with 40 confirmed victories and Major Thomas McGuire with 38. It was the aircraft that carried out Operation Vengeance, the mission that resulted in the loss of Admiral Isoroku Yamamoto, the architect of the Pearl Harbor attack when his transport was intercepted by P-38s over Bougainville. In total, P-38s would be credited with the destruction of more Japanese aircraft than any other American fighter in the Pacific. 1,800 confirmed victories. How many of those victories were made possible by improved aileron response? How many pilots came home because their aircraft turned just a fraction of a second faster? The exact number is impossible to calculate. But a military historian, decades later, would estimate that McKenna's modification saved between 80 and 100 American pilots' lives. Lieutenant Robert Hayes survived the war. He flew 63 combat missions and was credited with 11 confirmed victories. He returned to Iowa, got married, built a life. But he never forgot the morning of August 17th, 1943. Every year on that date, he made a phone call to California to thank the mechanic who had saved his life. McKenna continued his service as an aircraft mechanic for the duration of the war. He never sought recognition, never told the story unless asked. When the war ended, he returned to civilian life and eventually opened his own garage in Long Beach, California. He worked there for decades, just another mechanic, fixing cars and trucks, never mentioning that he had once fixed something else, something that mattered. It's worth examining at this point the broader implications of this story, because it's not just about one mechanic and one modification. It's about the nature of innovation in wartime, about the gap that sometimes exists between theory and practice, between the clean room where aircraft are designed and the muddy airfield where they fight. The P-38 was designed by some of the most talented aeronautical engineers in the world. The team led by Clarence Kelly Johnson at Lockheed's Skunk Works would go on to create some of the most advanced aircraft in history. They understood aerodynamics, structures, performance. They had wind tunnels and test facilities and decades of collective experience. But they were designing for specifications, for performance envelopes, for the theoretical combat environment described in military requirements. They couldn't fully understand what it was like to dogfight over the jungles of New Guinea, what it felt like to have a Zero on your tail, trying to get his guns lined up while you desperately tried to turn inside him. The pilots knew. They lived it. But pilots aren't engineers. They can describe what the aircraft does, but not always why it does it. They know the problem, but not necessarily the solution. The mechanics occupy a unique position. They work with the aircraft every day. They see how it's built, how the systems interact, where the tolerances are. They hear the pilot's complaints and observations. They're close enough to both the machine and the mission to understand the connection between them. This dynamic has played out throughout the history of military aviation. Some of the most important improvements in aircraft performance have come not from engineering offices, but from the field. From crew chiefs and mechanics who saw a problem and figured out a solution, often using nothing more sophisticated than basic tools and common sense. The modification itself is elegantly simple. That's part of what makes it remarkable. This wasn't a complex redesign requiring new parts or extensive machining. It was a bent piece of wire, 6 inches long, installed in 8 minutes. The kind of solution that makes engineers slap their foreheads and say, "Why didn't we think of that?" But simplicity can be deceptive. The insight required to identify that 3/8 of an inch of slack as the critical factor, that took knowledge and observation and analytical thinking. McKenna had to understand how the control system worked, how cable tension affected response time, how that response time manifested in combat. He had to connect cause and effect across multiple systems and recognize a problem that more senior engineers had missed or dismissed. And then he had to have the courage to act on that understanding, knowing he was violating regulations, knowing he could face serious consequences. That's perhaps the most remarkable part of the story. The willingness to take personal responsibility to say, "I know this is against the rules, but it's the right thing to do." The unofficial spread of the modification across the Pacific Theater is itself a fascinating phenomenon. No official directive was ever issued. No technical order came down from headquarters. Instead, the knowledge spread through the informal network of ground crews. One mechanic would tell another. A crew chief would demonstrate the technique to a colleague. When personnel transferred between units, they took the knowledge with them. This kind of grassroots innovation is difficult for large bureaucratic organizations to achieve intentionally. You can't order people to innovate. You can't mandate creative problem-solving through regulations and procedures. Sometimes the best ideas come from the bottom up, from the people closest to the problem, working outside the official channels. The fact that higher command eventually recognized the value of the modification and chose not to punish those involved shows a degree of organizational flexibility that's worth noting. In a military organization, where following orders and maintaining chain of command is crucial, there's always a tension between discipline and innovation. Too rigid, and you stifle the kind of creative problem-solving that can save lives. Too loose, and you risk chaos. Someone made the decision to look at the results rather than just the process, to recognize that while proper channels and official approval are important, the ultimate measure is effectiveness. Do the modifications work? Do they improve mission success? Do they bring pilots home? When the answer to those questions is yes, perhaps the procedural violations can be overlooked. The story also highlights the nature of technical innovation in wartime. In peacetime, aircraft development follows a careful, methodical process. Design, prototype, testing, evaluation, modification, more testing, certification, production. It can take years. Every change is analyzed and documented. Safety is paramount. But war doesn't allow for that kind of timeline. The enemy isn't going to wait while you conduct a proper test program. Pilots are facing threats today, right now. If you can make an improvement that will help them survive tomorrow's mission, waiting 6 months for official approval isn't acceptable. This creates a different kind of innovation pressure. Solutions need to be found quickly, implemented rapidly, with limited resources. Often the best becomes the enemy of the good enough. A perfect solution that arrives too late is worthless. A rough solution that can be implemented immediately and provides even a marginal improvement is valuable. McKenna's piano wire tensioner was hardly elegant engineering. It wasn't precision manufactured. It didn't come with engineering drawings or installation procedures, but it worked, and it was available immediately, using materials at hand, with tools and skills that any competent mechanic possessed. The P-38 itself deserves more examination to fully understand this story. It was, in many ways, an unusual aircraft for its time. The twin-boom configuration was distinctive and offered certain advantages. The engines were mounted far from the cockpit, improving pilot safety in case of fire. The tricycle landing gear made it easier to land than conventional tail draggers. The concentrated nose armament was devastating against bombers. But the design also created challenges. The P-38 was complex and maintenance-intensive. Those twin-turbo supercharged engines required careful synchronization. The control cables running through the long central nacelle out to the booms and then to the control surfaces were longer than in conventional designs. That length meant more opportunity for flex and slack in the system. At high altitude, where the air was thin and the P-38's turbo superchargers gave it an advantage, the aircraft performed beautifully. It was fast, powerful, and could outclimb almost anything. But down in the thick air at low altitude, where much of the fighting in the Pacific took place, it was heavier and less nimble than purpose-built dogfighters like the Zero. The Zero, by contrast, was designed from the beginning for one thing: turning performance. It was light, almost fragile by American standards. It lacked armor protection for the pilot. Its fuel tanks weren't self-sealing, which meant a single incendiary round could turn it into a fireball. But it could turn tighter and faster than almost any aircraft in the sky. Japanese doctrine emphasized maneuverability over protection. American doctrine emphasized firepower and pilot protection over agility. Different philosophies reflecting different strategic priorities and different cultural approaches to warfare. The Zero was, in many ways, the perfect expression of its design philosophy. So was the P-38. But in combat, these aircraft met on equal terms, and neither design philosophy guaranteed victory. It came down to tactics, pilot skill, and often small technical factors, like 3/8 of an inch of slack in a control cable. The Japanese pilots flying Zeros in 1943 were, for the most part, highly experienced. Many had been flying since the start of the war, since Pearl Harbor, or even before. They had developed tactics specifically for fighting American aircraft. They knew how to use their advantages in maneuverability. They knew that if they could draw a P-38 into a turning fight, they could usually prevail. Then, suddenly, that wasn't as reliable as it had been. The P-38s were turning tighter, responding faster. The comfortable margin of superiority that Zero pilots had enjoyed began to narrow. And in air combat, confidence matters. When you know you have an advantage, you fight more aggressively. When that certainty disappears, when the enemy becomes more dangerous and unpredictable, doubt creeps in. This psychological dimension of the modification's impact is hard to quantify, but shouldn't be underestimated. American pilots became more confident in their ability to engage Zeros. Japanese pilots became less certain of their advantage. Those changes in attitude affected decision-making in combat, influencing who pressed an attack and who broke off. The modifications spread across the Pacific theater followed the pattern of military units in combat. Units trained together, deployed together, shared information. A mechanic who discovered the modification would naturally want his entire squadron to benefit. When pilots transferred or when ground crews were reassigned, They took the knowledge with them. There was no conspiracy, no organized movement, just individual mechanics and crew chiefs, each making the same decision McKenna had made. This helps. This saves lives. This is the right thing to do. Regulations be damned. By the time the P-38J entered service in spring 1944, with its factory-installed improved aileron response system, the modification had already been in widespread use for months. The official version was more sophisticated, more carefully engineered, but the principle was identical, and hundreds of pilots had already benefited from the field modification. The P-38J incorporated other improvements as well. Better cockpit heating, which was crucial at high altitude, dive flaps, which helped address another dangerous characteristic of the early P-38s, compressibility at high speed, power-boosted ailerons, which further improved roll rate. Each of these changes addressed real problems that pilots and mechanics had identified in combat. But the genesis of the improved aileron response system can be traced directly back to that August morning at Dobodura, to a mechanic with a piece of piano wire who saw a problem and fixed it. McKenna lived until 2006. He was 88 years old. For most of his life, his contribution remained largely unknown outside the small circle of pilots and mechanics who had been there. In 1991, a military historian researching P-38 combat effectiveness in the Pacific discovered references to the field modifications and tracked down McKenna. The interview was recorded. McKenna, by then in his 70s, recounted the story matter-of-factly. No dramatics, no claims of heroism, just a mechanic who saw something that needed fixing and fixed it. When asked why he had done it, knowing he could be court-martialed, his answer was simple. Those were our boys going up there. Somebody had to do something. The historian estimated that the modification had saved between 80 and 100 American pilots' lives. That estimate is conservative, based on documented improvements in combat loss rates for units using modified P-38s compared to those using standard aircraft. The actual number could be higher, but precise figures are impossible to establish decades after the fact. 80 to 100 lives, 80 to 100 men who came home from the war, who got married, had children, built careers, lived full lives. The ripple effects of those saved lives are incalculable. How many children were born because their fathers survived? How many grandchildren? How many contributions to society were made by men who would have been lost? This is the hidden calculus of war. Every technical improvement, every tactical innovation, every piece of intelligence gathered can be measured not just in missions accomplished or enemies defeated, but in lives saved. And those saved lives create futures that would otherwise never have existed. McKenna's obituary in 2006 mentioned his service as an aircraft mechanic during World War II. It noted that he had served in the Pacific Theater. It mentioned his garage in Long Beach. But it didn't mention the piano wire. It didn't mention the modification that saved lives. For most people who knew him in civilian life, he was just a mechanic who worked on cars. The story of what he had done in the war was never widely known. This raises a question worth considering. How many other stories like this exist? How many other innovations, large and small, were made by people whose names never appeared in the official histories? How many mechanics and crew chiefs and ordinary servicemen saw problems and fixed them, saved lives, changed outcomes, without ever receiving credit or recognition? The historical record tends to focus on the big picture: generals and admirals, major battles, strategic decisions, the development of new weapon systems. But wars are fought by individuals, and often the most important developments happen at the individual level. A mechanic with a piece of wire, a pilot with a tactical insight, a radar operator who spots something unusual. These small moments, multiplied across millions of servicemen, determine the outcome. McKenna's story became more widely known only after his passing. The historian who interviewed him in 1991 eventually published an article. Other researchers followed up. Slowly, the story entered the broader historical narrative about the P-38 and the air war in the Pacific. But by then, McKenna himself was gone. He never sought recognition, never tried to claim credit, just did his job and went home when the war ended. There's something quintessentially American about that. The citizen soldier who serves when needed, then returns to civilian life without fanfare. The craftsman who sees a problem and fixes it, not for glory, but because it's the right thing to do. The individual who takes responsibility and acts, even when it means violating rules, because the situation demands it. These values, embodied in McKenna's actions, represent a tradition in American military history. From Valley Forge to Normandy to the jungles of Vietnam and the deserts of Iraq, American servicemen have demonstrated this combination of technical competence, individual initiative, and moral courage. It's not uniquely American, certainly, but it's a recurring pattern in how Americans approach warfare. The P-38 Lightning flew its last combat mission in World War II on August 15, 1945. The war in the Pacific ended that day with Japan's surrender. In 3.5 years of combat, P-38s had flown hundreds of thousands of sorties, engaged in countless dogfights, provided fighter escort for bombers, conducted reconnaissance missions, and contributed significantly to Allied victory. The aircraft had evolved considerably from the early models that first saw combat in 1942. Each iteration incorporated lessons learned in battle. Each improvement addressed problems that pilots and mechanics had identified. The P-38J and later the P-38L represented the culmination of this evolutionary process, incorporating all the field modifications and engineering improvements that had been developed throughout the war. But the foundation of that evolution, at least in terms of aileron response, can be traced back to McKenna and his piano wire, the field modification that spread mechanic to mechanic across the Pacific, the unauthorized fix that saved lives and improved combat effectiveness, the simple solution to a complex problem. In the decades since World War II, military aviation has become vastly more sophisticated. Modern fighter aircraft are controlled by computers, not cables. Fly-by-wire systems eliminate the mechanical linkages that created the slack McKenna identified. Artificial intelligence assists pilots in combat. The technological gap between a P-38 and an F-35 is almost incomprehensibly vast, but certain fundamentals remain constant. The importance of rapid response time in aircraft controls, the need for mechanics and maintainers who understand their aircraft intimately, the value of individuals who can identify problems and develop solutions, the necessity of organizational flexibility that allows good ideas to spread even when they don't follow official channels. McKenna's story remains relevant not because of the specific technical details of the modification, which are now obsolete, but because of what it represents about innovation, responsibility, and the human dimension of warfare. Technology matters, strategy matters, but individuals matter most. One person with knowledge and courage and a bent piece of wire can change outcomes, can save lives, can make a difference. The piano wire tensioner that McKenna installed on Robert Hayes's P-38 that August morning has long since disappeared. The aircraft themselves, the ones that carried the modification, have been scrapped or crashed or rest in museums, their control systems updated or replaced. No physical trace of McKenna's innovation survives, but the impact survives. In the lives that were saved, in the families that were created, in the victories that were won, in the historical record that documents the improvement in P-38 combat effectiveness in the Pacific Theater, and in the example set for future generations about individual responsibility and moral courage. Sometimes the most important innovations are the simplest. Sometimes the biggest impact comes from the smallest change. And sometimes the real heroes are the ones whose names never make it into the history books. the mechanics working in the heat and the mud, the crew chiefs keeping aircraft flying under impossible conditions, the ordinary men who do extraordinary things without fanfare or recognition. James McKenna was one of those men, a mechanic from Long Beach, California, who served his country, saved lives, and then went home and fixed cars for the rest of his life. No medals, no parades, no recognition until decades later, just a job well done and the quiet satisfaction of knowing that what he did mattered. On August 17, 1943, at 7:42 in the morning, he made a decision to violate regulations, to trust his judgment over official specifications, to take responsibility for the lives of pilots he would never meet. It took him 8 minutes to install the modification. It was a decision and an action that would echo across the Pacific theater, save dozens of lives, and eventually find its way into the official design of one of World War II's most important aircraft. 8 minutes, one piece of piano wire, one mechanic who saw what needed to be done and did it. That's how wars are won, not just by generals and admirals moving divisions on maps, but by individuals making decisions, taking action, accepting responsibility. One person at a time. One problem solved at a time. One life saved at a time. The P-38 Lightning, with its distinctive twin booms and powerful engines, remains one of the most recognizable aircraft of World War II. It appears in photographs and films, in museums and airshows. When people see it, they think of speed and firepower, of island-hopping campaigns and dogfights over the Pacific. Few know the story of the mechanic and the piano wire. But that story is as much a part of the P-38's legacy as any mission it flew or any victory it achieved. Every aircraft that came back, every pilot who survived, every mission that succeeded because the aircraft responded just a fraction of a second faster. That was McKenna's legacy, written not in official reports or medal citations, but in lives lived and futures created. The most important kind of legacy there is,